To start, click button 3 to activate the evaluation program. Select a measurement from your sample number and double-click. Warning: when selecting a measurement, never hit cancel. If you hit cancel and run an evaluation, your data will be invalid. If you have already chosen your measurement of interest and wish to stay on this measurement, simply double-click the measurement again. In order to perform trabecular analysis, we must first identify the trabecular region of the bone. If there is more than one bone in the scan, refer to the sketch you should have made illustrating the position of the bones in the toothpick, and begin with the bone in position 1. Note: the following instructions assume you scanned the entire bone length. For trabecular analysis, we recommend conducting the evaluation over a 1.5 mm length of the metaphysis at a 7.4 micron resolution. This is equivalent to about 200 slices directly adjacent to the metaphyseal growth plate. That being said, the first step in identifying the trabecular region is identifying the location of the growth plate. To do so, we look for the following progression. As can be seen here, the growth plate can be recognized by the 4 ovals that constitute the crown of the plate. As we get closer to the metaphyseal region, the ovals begin to merge, and we can see here how the trabeculation in the bone progressively increases as well. Here we can see that the middle of the bone has opened significantly since the first picture. We denote this as the starting slice of the metaphyseal region. The transition between the last 2 stages can often be tricky to distinguish, and for this reason, the identification of the starting slice will vary from user to user. For more help in identifying the growth plate, the metaphyseal region, or the starting slice, see the lab manager. Once a trabecular region has been identified, go to the Zoom menu and select a magnification of your choice to zoom in on the bone of interest. The suggested magnification is 4 times. Select the starting slice of the region and click on C. Contrary to cortical analysis, we will now be drawing our contour in the inner border of the shell of the metaphyseal cavity as opposed to tracing the outer surface. To draw a contour, first hit the lasso button on the top left, hold down the mouse and trace in a counterclockwise motion. Release mouse once tracing is complete. Because the contours are now being drawn on the inner border, the contour thresholds need to be flipped. For trabecular analysis, the recommended thresholds found in the contouring window are 530 for the outer and inner thresholds respectively. Contour thresholds aid the computer in integrating our area of interest across the many slices of the bone measurement and save the user from going through each slice and drawing the contour every time. Note: contour thresholds are different from evaluation script thresholds and do not need to be the same between bones. Once you are satisfied with your thresholds, choose backwards in the selection column and click Iterate Backwards to begin iterating the trabecular region. The contour may misbehave slightly while iterating. If so, stop the iterations, go back to the slice with the error, and use the freehand adjustment tool to correct the mistake before continuing to iterate. Hit Iterate Backwards again to resume iteration. In the case the bone does not allow you to use the automatic iteration tool, draw contours by hand intermittently, say every 10 slices. Try to hit key frames where the shape of the bone starts to change, and then use the morph tool found in the contouring window to fill in the gaps. Note: interpolated slices will show up as red. This doesn't mean they are bad, just interpolated. You may need to increase or decrease the frequency of drawing contours by hand depending on the size and shape of the bone. Once you have drawn all your contours and morphed or iterated as needed, click T. A window titled 3D Evaluation will pop up where you must choose an evaluation script that specifies which pixels are going to be evaluated as bone in the image analysis. Evaluation scripts should be set per experiment under the advisement of the lab manager. Note that, unlike the contour thresholds, the same evaluation thresholds must be used for all measurements in the analysis. We will have a separate instructional video explaining the process of choosing appropriate evaluation thresholds that will favorably align with all samples in an experiment, not just in a single measurement. Once the evaluation script has been chosen, hit Default VOI, then hit Start Evaluation. Defaulting the volume of interest is extremely important, as forgetting this step will stall your analysis because the software will try to analyze a square of black space, searching aimlessly for bone that it will never find. Further, when evaluating other samples in the same measurement, this step is important to adjust the analysis region to your current bone of interest from the previously contoured and analyzed bone. Hit Yes to save all contours when prompted. Note the specimen number and the time at which you complete this step in your lab notebook, as the timestamp will allow you to keep track of the order of the output file. You can check the status of the analysis by typing QUE in the deck term window, which should already be open in the background. In this window, you would also find a completion message once the analysis of that specific bone in the measurement has finished. Note: if the deck term window is not already open, navigate to the toolbar at the top of the screen, find Applications, and finally select Deck Term from the drop-down menu. Important: do not begin the contour tracing and analysis of another bone in the same measurement while an analysis is already taking place. Wait until the previous analysis has finished, then move on to the next bone. Once completed, clear previous contours by hitting the X button. Click Yes to confirm. Note: when performing this step, you are not erasing the contour data from the previous bone analysis, but rather you are clearing the canvas to make way for the next set of contour iterations. Repeat this procedure if multiple measurements need to be analyzed within the same experiment. Note: you may complete these analyses in different user sessions.